Welcome again, Wildcats. All right, before I get started on the lesson, I'm going to give a shout out to the Matthew Isle team, which took third place in all events. That means we beat every team in our district except for two teams. And those two teams, we're coming for you. Okay, we're going to beat you next year. Okay, so watch out for Temple High School, Matthew Isle team. We're coming for you. All right, but I just want to thank you for all your hard work. You did a great job, and I'm very Wildcat proud of you. All right, so with that, today we're looking at Friday, March 24th. We're looking at logarithmic transformations on page 66. So if you would, pause your video and update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, so we're looking at logarithmic transformations. Okay, so we're looking at f of x equals log base 2 of x. And here's the transformation. So if you would, pause the video and then update this function with the transformations. All right, now that you have that updated, let's take a look at the transformations themselves. And I think I can get them all in the screen. All right, so when the negative is in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the b value, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. So if you would, pause for a few seconds and update your notes. All right, now your notes are updated. Let's take a look at our examples. Let's start with example 1. All right, so first off, the transformation is down 5 units. Okay. So let's go ahead and do that. Now we know in exponential, okay, that it's 0, 1 is our parent point, and I shouldn't put a point there, but we'll just note that that's where we start. And so from there we go down 5. So down 1, 2, 3, 4, 5. Okay. Now our asymptote, we know, is the plus or minus k value here, so we know it's y equals negative 5. Okay, and let's go ahead and graph that asymptote. All right. Now, to find our y-intercept, we know that x is 0, so that's f of 0 equals 2 to the 0 power minus 5. Well, we know anything raised to 0 power is 1, so 1 minus 5 is negative 4. So our y-intercept is 0, negative 4. So let's go ahead and graph 0, negative 4. All right. At this point, you could get more points, but we just want you to understand that the curve of the exponential function looks like that. And since I graphed this on you, I'm just going to put a box in here to just remind myself that this is that line. All right. We know the domain is all real numbers, and our range is y greater than negative 5. Now, you're probably asking yourself, Mr. Luke, you said in the beginning that we're doing logarithmic function transformations. That's an exponential function transformation. And you're right. But I wanted to show you the connection between exponential functions and logarithmic functions first to move you to that, kind of merge those together as we move into logarithms. And here's that merging moment. The inverse of an exponential function is a logarithmic function. Okay, so they're inverses of each other. And if they're inverses, we know that we switch the x and y, the domain and range, okay, and the asymptote. So if the asymptote in the exponential is y equals, and this exponential is y equals negative 5, we know the inverse is going to be x equals negative 5. Okay, we know the domain and range switch. So if the domain in exponential is all our numbers, the range is going to be all our numbers. And if the range is y greater than negative 5, we know the domain is going to be x greater than negative 5. And we know the x and y switch. So if we take a point, we'll switch x and y. So if we take the point 0, negative 4, becomes negative 4, 0. Okay. All right, so pause for a few seconds to update example 1. All right, so let's look at example 3. All right, example 3. And same thing here, I'm going to end up graphing this in yellow, so just boxing around to remind myself that that's in yellow. All right, so transformations. So it's minus 6, so we know it's right 6 units and up 4 units. Okay, so let's go now. Remember that in exponential we always started at 0, 1, but because we know a logarithm is the inverse, so we switch, so we're actually going to start at 1, 0. Okay, so from 1, 0, we're going to move 6 units. So 1, 2, 3, 4, 5, 6, and we're going to go up 4 units. So 1, 2, 3, 4. So there's our key point, 7, comma 4. All right. Now, we knew from an exponential that the plus k value was where we could find the asymptote, but we know since we switch, we're actually looking at the h. So our h value is actually where our asymptote is, and we know in exponential is y equals. So in logarithm, it's going to be x equals. So our asymptote is x equals negative 6. All right. And since we know that this didn't reflect, we just have the logarithmic function here. All right. So we know the domain is x greater than negative 6, and our range is all real numbers. All right. So with that, go ahead and try example 2 and example 4 before class, and then just let me know which examples we need to go over, if any, if none, on Friday. So with that, have a wonderful Wildcat night or day or morning, whichever point in your life you're watching this video. So